Okay, this is a video for my 40S Essential class. We are going to go through the stats review. Our test is next class. So, first question, which measure of central tendency should the manager of a shoe store use to order the most common size of shoe? Well, if the shoe store were to add up the shoes that they sold and divide by the number of shoes that they sold. Sorry, let me say that again. They add up all of the sizes. So somebody comes in with a size 7, then somebody buys a size 7, then somebody buys an 8, then an 8.5, etc. If you add up all those sizes and divide by the number of things, you might get 9.3 or 8.7. And what's he going to do? Phone up his distributor and say, hey, get me a bunch of 8.7s. They're flying off the shelves. That's my average shoe size that I'm selling. Obviously, that would be ridiculous. So mean and median, I mean, they might represent the center of my data, but mean and median may not represent his most common size sold. So he should use mode. The most common kind of shoe he sells. I mean, kind of, it's almost built into the question. Most common. Most often happens. That's what mode is. So I guarantee you a question something like this, where we ask you to judge what's better, median, or mode. Okay, Ramon has a summer job at a paper mill. He measures the acidity, the pH in a particular tank, and he gets all these results. Everybody from chemistry remembers that 7 would, of course, be neutral. Basically, that's the pH of water, right? So take a look at all these pHs. They're all higher. Does that mean that they're acidic or basic? Who remembers their chemistry? Well, except for one that's ridiculously low. The lower it is, the more acidic it is. So these would be caustic, basic, right? So, except for this one, which would be such a strong acid that I doubt you could hold it in a glass vial. I don't know that there's any acid in the world that's actually that acidic. But anyway, I would wonder that that was some sort of measurement error if I was looking at this data in a real world. Okay, hang on. Yeah, you put in the pH paper and it would disintegrate in that, I would think. Okay, anyway, well, this is the data. We got to treat it with respect. So here we go. 7.8 plus 7.9 plus 7.7 plus 7.8 plus, I'm just going to combine those two numbers, 8.8 plus 8.1. And then I'm going to divide all of that by 1, 2, 3, 4, 5, 6, 7 pieces of data. And when I do that, I'll save you the trouble of the calculation. You should get 6.86 repeating, I think is the way it turns out. So it ends up being, so I'll round it to two places. It'd be 6.87. I guess it's actually it'd be 0.87152 repeating or something like that. Okay, so 6.87. The median, okay, I got to put them in order. So the 0.8 is first. Cross it off so you don't count it again. Then the next smallest is 7.7. Meh. And then there's a couple of 7.8s. Meh. Meh. And then there's a 7.9. And then there's an 8 and an 8.1. Meh. Meh. 1, 2, 3, 4, 5, 6, 7. I got them all. So the median of 7 things is the fourth thing. So the median is 7.8. There we go. The mode is the one that happens the most often, which is also 7.8. The range of my data set is the biggest minus the smallest. So that would be 7.3. And if I were to get rid of the highest and lowest value, I'd do a trimmed mean. So that would now be get rid of that 0.8 and get rid of the 8.1. So it would be 7.7 plus 7.8 plus 7.8 plus 7.9 plus 8.0. And now we're dividing by 5. And when you do that, you would, I'll save you the calculation, you get 7.84. And notice that changes things a fair amount, right? Our original median was way down under 6. According to our original mean, the average pH is acidic, less than water. But according to our trimmed one, it's quite basic, quite caustic. That's a big difference. All right, a swimming coach orders team suits. These are the sizes. What is the mode of the set? Now, I was looking through it, and I noticed, oh, there's a couple of 6s, but I think 8 wins, right? There's an 8, there's an 8, there's an 8, there's an 8, there's an 8. So 8 is for sure the mode. Is the mode the best way to represent the typical suit size? Yes. You probably thought they were going to throw you a curve, like, oh, the answer's probably wrong. Why would they be asking? No, this time it's yes, definitely. Again, the word here is typical, right? It actually, because again, it's the most common. It's like 40-something% of the data if you added it up. It's the most common, I'll say even by far. And if you actually did, I did this with the morning class because we were just, killing some time. But if you actually did add this up and find the median and the mean, actually 8's not very far from either of those numbers. So it wouldn't be a bad average either. So not only is it typical, it is also a good measure of center. Mode isn't always a good measure of central tendency, but in this case, yeah, some of the data is a little bit bigger, some of the data is a little bit smaller. It's pretty good. So mode would make a good average here. So that's number 3. Now number 4. Not too many people in the morning class got this one. Every one that we've done like this, we've always had these weightings given to you as a percent. Clearly, first of all, you don't see a percent symbol anywhere, so you don't think it's a percent. But even if you maybe for a second thought those were percents, what would convince you maybe quickly, oh, those can't be percents? It doesn't add up to anywhere near 100, so those can't be percents. So your job is to turn these into percents. Actually, more importantly, to turn them into decimals. What decimal of the data is 3? Well, the data is that we're adding up English, math, chemistry, history, and phys ed, and if you add up all those weightings, you get 11. So in other words, this English mark of 80 is going to be 3/11ths of his grade. And math is going to be another 3/11ths of his grade. Chemistry will be 2/11ths. History will be 2/11ths. Phys ed will be 1/11th. And then I pointed out to somebody in the morning class that now you can see if you add those up, remember that when you add fractions, you don't change the denominator once it's the same? 3/11ths, 6/11ths, 8/11ths, 10/11ths, 11/11ths. What do you know about 11/11ths? Oh yeah, that's 1, which is 100%. Ah, there's my 100%. Does that make sense? That's what you were supposed to do with this. Now, how many people actually have a fraction button on their calculator? Break it out, okay? It says in our notes that we change them to a decimal. Yeah, but that's when we started off with a percent. It's actually easier to work with the fractions. If you have a fraction button especially, let's do Gerard first. If you have a fraction button, you can say 3/11ths of 80 plus 3/11ths of 75 plus 2/11ths of his chemistry mark, 85, plus 2/11ths of his history mark, which was 90, add 1/11th of his phys ed mark equals his grade. And I had somebody this morning who said, I hate fractions. Some fraction haters out there. And okay, well, fine. You can hate fractions all you like, but if you're going to round these to decimals, see, this person just took this and 3/11ths. They used their calculator and 3 divided by 11 and found out that that's 27%, so they rounded it to 0.27. Now, the problem with that, what makes that problematic, is that 3/11ths isn't exactly 0.27. It's actually 0.27 repeating. It's 27, 27, 27, 27 forever. So when they did their calculation, I'm going to do it in red here, they went 0.27 times 80 and 0.27 times 75, And now my pen's dying. There we go. And 2/11ths is actually 0.18 repeating, but once again, they rounded it to 0.18 times 85. And so then it'd be 0.18 times 90. And 1/11th is actually 0.09 repeating. 09, 09, 09, 09 forever. Again, they didn't like the fraction, and they didn't feel like punching a whole bunch of buttons for decimals, so they rounded it, and the two answers came out interesting. The answer for the one that you did here, where you actually used 3/11ths, by the way, if you don't have a fraction button on your calculator, you can just go 3 divided by 11 and then times 80. That's how you would do that button punch. It's really not that hard. It's a lot easier than typing in 0.07070707 until you run out of room on your screen. I don't know that you'd need that many decimals, but you'd want at least 4 or 5 decimals to make sure that it rounds properly, because these numbers, there's a lot of numbers here. So that's what we did this morning. We compared these answers, and we found out that if you do this, you actually get 81.81, I think it's 81 repeating, % for Gerard, it's Gerard, not Gerald. In fact, maybe I'll double check that. Okay, this didn't work very well this morning. I'm going to try it now. Let's see. Oh, look at this. My screen goes, okay, I know how to fix this. I have to shrink this so it's not full screen. Then I can do it. Ah, there we are. Okay, so turn on my calculator. Clear the stuff I was, clear the stuff I was playing with this morning. Okay, move over a bit. Okay, so I would do this. I don't have a fraction button on this fancy calculator, so 3 divided by 11 times 80 plus 3 divided by, 11 times 75 plus 2 divided by 11 times, okay, my calculator's in the way. What was that number? 85. That was his chemistry mark, right? Plus 2/11ths of 90 plus 1/11th of his phys ed mark, 85. And when I do that calculation, I get 300. Something's wrong with that. Okay, we typed wrong. What did we do wrong? Oh, okay, I see the problem. This is supposed to be 3/11ths, it's 3/1. I can fix that. No, not like that I can't. Let me try that again. No, it's not doing it. Yeah, this button when I hit this should actually, there we go. The third time, I'm pretty sure I hit the right button. Okay, there we go. Now I can go back to where you were. And we can go back and we can fix that 3/1 that's supposed to be 3/11. Come on. Man, it's almost like this app is not working like I should have paid more dollars for it or something. Okay, oh, you know what? That's not going to work either. I'm going to have to go second function, insert, and then add another 1, then go to the bottom. I don't even know if I have to go to the bottom, but I will. Then hit enter. Aha, I was right. It's 81.81 repeating. So if you're actually looking at what that is as a grade, what would you do with that grade? You'd round it to 82. There we go. He got an 82. If you did just the decimals and rounded them, let's do that really quick. As quick as I can on this calculator anyway. 0.27 times 80 plus, and let's see, 0.27 times 75 plus 0.18 times 85 plus 0.18 times 90 plus 0.09 times 85. Uh-oh, we just gypped Gerard out of a %. It's like, but I rounded them all to 2 decimal places. Yeah, but the cumulative effect of all of those little roundings made the number smaller than it was supposed to be. So, if I'd have actually gone through here, and again, I could amend this if I wanted to, and I actually put more decimals on all of them, like I could go up to this 27 here and insert and make it 2727. There we go. And then if I did that to all those decimals, I would get closer to the answer I'm supposed to get. But isn't that more work than just punching in the fractions? People always assume decimals are easier than fractions. They have drawbacks. Okay? So I would recommend going with the fractions. The other part of this question that's interesting is, if you did it the red way, and you only got, what was the answer here, 81, you actually can't answer the next part of the question. Because when you do Mary's calculation, Mary here is going to be, so let's do Mary's. Oops, come on, pen. Mary would be 3/11 of 70 plus 3/11 of 84 plus 2/11 of 74 plus 2/11 of 98 plus 1/11 of 88. And when you do that, she ends up being 81.3. So she rounds to 81. So the second part of the question, Gerard has a higher average, but notice, again, if you use these decimals for Mary, you would still get 81. This wouldn't round all the way down to 80 point something. So you would actually not be able to answer this question properly if you used rounded numbers. Because who had the higher? They both had exactly 81. So when in fact, when you look at the actual decimals, nope. Gerard rounds to 82. Mary would stay at 81. There is a right answer here. But you'd only get it by being accurate. And I bet they designed this question that way on purpose. All right, any questions? I won't do this to you in the test. When we give you a weighted mean question, we will give you percentages. Okay? So there we go. So there's a neat question. Okay, number 5. Number 5 has a mistake in the answer key here. Oh, it has a mistake in the question, not the answer key. Anybody catch the mistake in the question? Glenn scored 36 out of 50 at a dance competition. He did not win the top prize, but he was pleased with his rank. The score of 8 other dancers. Anybody count this? There's 9 numbers there. 9 other dancers. Oops. Okay, so that's a mistake. All right, what's his percentile score? Percentile score, percentile rank. First, the first question is, at what percentile is a score of 36? So the percentile rank for 36 is how many numbers are smaller than 36? Well, 1, 2, 3, 4, 5, 6. 6 out of 9 times 100. And oh, I bet you could do that in your head. Anybody know 6/9 as a decimal? Hint, it's 2/3. It's 0.6 repeating. And remember that when you do this, 66.6 repeating, you round down when you're doing percentile ranks. So his percentile rank is 66th. Shouldn't we add what? At what percentile is a score of 36? 20, 32, so 1, 2, 3, 4, 5, 6. 6 or below. Oh, right, it's out of 10. Oh, that's right. There was 9 other scores. You're right. I've got the wrong answer here. So 6 out of 10, so that's actually the 60th percentile. Thank you for noticing that. I fixed this, and then I forgot that we fixed it. And I don't remember. Does the answer key have what I had? Oh, the answer key is the correct answer, so that's just the typo right there. Yeah. Okay. What does the answer in A mean? I remember giving a question like this in a test once, and kids give me an answer like, it means Glenn's a really good dancer. It's like, well, I don't mind that answer, but I'm not giving it a mark. Sorry. There you go. That's what we want. It means Glenn scored better than 60% of his, I'll use the word competition and pretend I know how to spell it. Competition. Is that right? That looks right. Yeah, there we go. Okay. What score is at the 50th percentile? that's kind of a coded way of asking you for what? I'll give you a hint. It's one of the M's. Is it the mean? No, it's the median, right? It's the middle number. What's the 50th percentile? So you could do it that way. You could calculate the median by going, okay, there is 10 numbers here. I better put his number on there, Glenn's number. So there's 10 numbers here, so I need what's between the 5th and 6th number. So here's the smallest. So 1, 2, 3, 4, 5, and what's the next number after 33? 1. Oh, wait a minute, I missed one. Oh, hang on. I'm going to start over. I missed the 25. How did I do that? I don't know. 1. Oh, whoops. I want to circle it. I'm going to cross it out. 1, 2, 3, 4, 5, and let's see. So 1, 2, 3, 4, 5, and 6. So there we go. So that's. What's that?
You canceled out the 33 before the 32s.
Oh, did I? Okay, let's try that again. Third time's the charm. 1, 2, 3, 4, 5, and 6. Oh, there it is. Yeah, that's what happened. That's what we got this morning. So we want the number that is halfway between 32 and 33. You can use that formula. Some of you could just know it logically. It's 32.5. And that is, by the way, the answer that the answer key gives. So 32.5. Or you could have actually used the percentile formula. But I got to point out, if you use the percentile formula, you would have rounded this down to 32. The answer key did say 32.5, so they must have done it this way. On a test, I'd actually have to accept both answers because you should be able to do it either way and get the right answer. Okay? All right, next. This one also has a typo, but this time it's in the answer key. In Ms. G's gym class, 40 of students, they are playing dodgeball. Man, I thought I had bad grammar. Class of 40 students, they are playing dodgeball. How about get rid of the they? Let's try that again. In Miss G's gym class of 40 students. Oh, no, that doesn't work either. In Miss G's gym class of 40 students. Miss G's gym class of 40 students are playing dodgeball. Bobby loves dodgeball, and 26 students have a lower dodgeball record than him, and 4 have the same as him. Find his percentile rank. All you care about are the numbers below him. And there's 40 students times 100. And I've punched this button before, and what did I get? I don't remember. I got the 65th percentile. This is actually 65. Oh, yeah, because it's 13 out of 20. 13 out of 20 is 0.65. So it's the 65th percentile. What percent of students have a record better than Bobby? Oh, if they had asked me which ones have a lower, I'd just say 65%. But better means I got to start with the fact that there's 40 kids, take away the 26 that are lower, and take away the 4 that tied him, and then don't forget to also take away Bobby. So, right, so this is, again, I'll write it out. This is the students who are lower than him. This is the students that tied with him. And this is him. So who's higher? And forgetting that one is a very easy mistake to make. So don't do that if you get a question like this in the test. 26 plus 4 is 30. 30 plus 1 is 31. 40 minus 31 is 9. And it does say what percent, not how many. If it had said how many students, I'm done. But it said what percent. 9 out of 40 times 100. And I don't remember what that number is. Is it 22.5? That number seems to be in my head. I think that's right. 9 divided by 40 is, yep, 22.5%. And if you look at the answer on the answer key, I have no idea where they got their number from. They say it's 35. That's not even close to right. Where do they?
They didn't count the people who tied.
So they counted the people who tied as part of the people who had a better record. So that's a mistake. Yeah, so that's a mistake. So the right answer should be 22.5. All right, next. Usain scored 85% on his health exam. There were 199 other students also who wrote the same exam. No one received the same score as he did, so no ties this time. His percentile rank was 68. How many students received a lower score? Ooh, algebra. because my formula is percentile rank is B over N times 100. Okay, well this time they tell me the percentile rank is 68. Okay, we don't know how many students were below him. We do know that there was 199 other, so when you count Hussein with that, that's 200 students. And I had some people this morning who got that far and didn't know what to do. And again, basic algebra means undo what's happening to the number I'm looking for. This number is being divided by 200 times by 100. What's the opposite of timesing by 100? So I'm going to divide both sides of the equation by 100. On this side it cancels, and on that side I now have this. Now my b is just being divided by 200. What's the opposite of dividing by 200? Multiply by 200, and 200 times 68 is 136. Guarantee you a couple of places on this test where you'll have to do some basic algebra. Might be one like this, might be one where there's a missing test score like you saw in the assignments. All right. Use your words. Explain the difference between Jill receiving 80% on a test and being the 80th percentile for the test. Okay. 80% is her grade or score on the test. It tells us, I'm going to use lots of words, she got 80% correct and 20% wrong. Right? That's what a grade means. You got 80% on a test. It means you got 20% wrong. What does her percentile tell us? The 80th percentile. Notice this is not a percentile rank, so that means there may be people who tied her. So the 80th percentile means that she scored as well or better than 80% of the, I don't know if it's one class, so I'll just say students. So there we go. There's a good answer for that one. I'll give you a sec to catch up to me. Make sure you understand percentile and percent don't mean the same thing, and you understand which one means which. Guarantee you there'll be some sort of question that tests that knowledge on Monday. Finally, explain why a student might request that her course mark be calculated using a trimmed mean. Well, there you go. Okay. Perhaps she has one very low test score when compared to the rest of her average. Trimmed mean will keep that score from, oh, I'm going to use that fancy word again, skewing her grade too low. And there we go. That was the review. Okay, I'll stop my video there.